Hello again. Let's continue with filtering in frequency domain. Filtering in frequency domain consists of modifying the Fourier transform of an image, then computing the inverse transform to obtain the result. The steps are as follows. 1. Compute Fourier transform of the image, FUV. Second step is multiplying the result by a filtering transfer function, f times h. Last step is take the inverse transform to get the filtered image. The link between filtering in the spatial and frequency domains is the convolution theorem, where the convolution in the spatial domain becomes product in the frequency domain, and vice versa. We get image smoothing by using low-pass filtering, which reduce the high frequencies. We will talk about two types, ideal low-pass filter and Gaussian low-pass filter. Ideal filter passes all the frequencies within a circle and cuts off all frequencies outside these circles. It has the following transfer function, where d0 is the radius of the circle, and duv is the distance between any point and the center. For example, we have this image which has a lot of noise, and its Fourier transform. We notice that the noise is in the high frequencies, so we will use ideal low-pass filter to delete the high frequencies. And this is the result of filtering. Let's implement this in Visual Studio. Previously, we write functions for shifting and calculating discrete Fourier transform. So first step is to compute DFT of the image. Then we will construct transfer function of the filter. Let's start with ideal filter. We will initialize all values of h by 1. For every pixel in the Fourier image, we will compute the distance between this pixel and the center of the image. If distance is greater than d0, we change the pixel value to 0. Now we have FUV and HUV, so we will multiply FUV with HUV. Here we need to center the Fourier image as we said before, but we can instead shift the filter image. Finally, we take the inverse Fourier transform of the filtered image and show the result. Now for Gaussian filter, the transfer function has the following form. Thank you for your attention.